We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. Take a look. The striking infrared images were taken this summer by the James Webb Space Telescope.
Billions of miles away, at the edge of our solar system, a mysterious event has just shaken the scientific world. The James Webb Space Telescope, humanity's most advanced eye in the sky, has detected something shocking. A colossal object, possibly the size of a moon, has collided with Neptune, the ice giant of our cosmic family. What does this mean for us? What really happened on that distant blue planet? And why are scientists both terrified and fascinated at the same time? Let's dive deep into the mystery. Neptune has always been something of a forgotten sibling in the solar system. While Mars receives the spotlight for potential colonization, Jupiter and Saturn fascinate us with their size and rings, and Venus intrigues us with its hellish atmosphere. Neptune often drifts quietly in the background. But Neptune is far from ordinary. It's the eighth planet from the Sun, orbiting nearly 4.5 billion kilometers away. Its deep blue color comes from methane in its atmosphere, and its winds are the fastest in the solar system, some racing at over 2,000 miles per hour. Despite its beauty, we know very little about Neptune. Only one spacecraft, NASA's Voyager 2 in 1989, has ever flown close to it. For decades, Neptune was little more than a faint blue, rarely observed with precision. But then came the James Webb Space Telescope, JWST, with its infrared vision powerful enough to pierce through the darkness of space. In 2022, Webb turned its golden mirrors toward Neptune, and for the first time in over 30 years, humanity saw Neptune in incredible detail. What Webb revealed was breathtaking: glowing rings, dynamic storms, and mysterious heat patterns suggesting strange atmospheric activity. But no one expected what Webb would uncover just months later. In the early hours of an otherwise ordinary observation cycle, Webb was scanning Neptune as part of a routine program. But then a sudden flash of infrared light appeared. It was not from Neptune itself, but from above its clouds, a massive expanding plume. At first, mission operators thought it was a calibration error or cosmic ray interference. But when Webb's instruments rechecked, the data was undeniable. Something gigantic had just struck Neptune. The impact sent shock waves through Neptune's upper atmosphere, releasing heat that Webb's infrared sensors immediately picked up. The glow was enormous, larger than anything expected. Within hours, the scientific community erupted. Messages flew across NASA, ESA, and observatories worldwide. Webb just caught something hitting Neptune. But what exactly collided with the planet? Here's where things get interesting. Neptune orbits in a region teeming with icy bodies known as the Kuiper Belt, a cosmic graveyard of frozen rocks, comets, and dwarf planets left over from the solar system's birth. Pluto itself lives here. Occasionally, objects from the Kuiper Belt drift inward due to gravitational nudges, but most of them are small, mere ice balls a few kilometers wide. Webb's data, however, suggested that the object striking Neptune was anything but small. Based on the brightness of the impact plume and the energy released, astronomers estimate the colliding body could have been 50 to 200 kilometers wide, potentially larger than some known moons. If true, this would be one of the largest planetary impacts ever directly observed in real time. To understand how significant this is, we need to look back in time. Planetary collisions are not rare in the universe. In fact, they're part of how planets grow and evolve. Earth itself bears scars of such impacts, most famously the one that formed our moon around 4.5 billion years ago when a Mars-sized body called Theia slammed into the young Earth, throwing molten rock into orbit that eventually coalesced into our moon. Jupiter and Saturn are constantly bombarded by comets and asteroids, their immense gravity pulling space debris inward. The most famous example is the Shoemaker-Levy 9 comet, which shattered and crashed into Jupiter in 1994, leaving Earth-sized scars on its atmosphere, visible even through small telescopes. But Neptune? No one had ever witnessed such an event there. For decades, it had remained silent and unbothered. Now, Webb was telling us a different story. The outer solar system is far more active and dangerous than we thought. When the object slammed into Neptune, it likely exploded high in the atmosphere before reaching the deeper layers. Unlike rocky planets such as Earth, Neptune doesn't have a solid surface. It's an ice giant with layers of hydrogen, helium, water, and exotic ices. The impactor probably disintegrated violently in the upper atmosphere, releasing enormous heat and energy. But here's the astonishing part. Webb recorded waves of turbulence spreading across Neptune's atmosphere like ripples in a cosmic ocean. These waves moved faster than expected, suggesting the atmosphere responded dynamically to the strike. Ground-based telescopes were quickly turned toward Neptune, and even though Earth-based observatories couldn't match Webb's precision, some were able to detect subtle brightening in Neptune's infrared spectrum, confirming something real had happened. This was no false alarm. Neptune had just been struck. Naturally, whenever a cosmic collision is reported, one question echoes in the public's mind. Could Earth face the same fate? The short answer is yes. But impacts on Neptune's scale are far rarer closer to the Sun. Earth is protected to some degree by Jupiter, whose massive gravity acts like a shield, pulling in or redirecting many dangerous objects. Still, Earth has been hit before and will be hit again. The difference is that Neptune's impactor came from a region of space far beyond Earth. The Kuiper Belt is home to countless icy bodies, and while most stay out there, gravitational interactions with Neptune can occasionally send them hurtling inward. Ironically, Neptune itself acts as a cosmic shield for the inner planets, absorbing blows from massive objects that might one day wander closer to us. In a strange way, Neptune may have just taken a hit for the entire solar system. But scientists aren't satisfied with just confirming an impact. They want to know exactly what hit Neptune. Was it a rogue comet, a wandering Kuiper Belt object, or something stranger? Webb spectrographs captured faint chemical signatures in the expanding plume. Early analysis suggests water ice, methane, and ammonia, common in comets and icy bodies. However, there was also something unusual: traces of heavier compounds not typically found in small comets. Some speculate the object may have been a fragment of a dwarf planet, a truly massive body shattered long ago and now drifting through space. If that's the case, this was no ordinary collision. It was a planetary-scale event. The discovery didn't stay secret for long. Within hours of the James Webb Space Telescope detecting the flash above Neptune, the astronomical community entered a frenzy. This was not just another comet sighting or a distant gamma-ray burst. This was a direct impact on one of our solar system's planets happening in real time. The race to understand it had begun. When the data first came in, NASA and ESA scientists cross-checked it multiple times. The Webb team knew the world was watching every move they made, and claiming a planetary collision was not something they could announce lightly. Emails flew across continents. Calls buzzed between observatories. Before sunrise in the U.S., astronomers in Europe, South America, and Asia had already been alerted. The raw data was shared in encrypted channels. The goal: confirm, confirm, confirm. By the time morning arrived, the verdict was unanimous. This wasn't noise. It wasn't a false reading. It was real. Something gigantic had hit Neptune. Within 24 hours, the first official press release went out. The headline read, "James Webb Space Telescope detects massive impact event on Neptune." News outlets erupted. Social media exploded. For the first time since Voyager 2's flyby in 1989, Neptune was trending worldwide. Immediately, Earth's most powerful telescopes were redirected toward the blue giant. The Keck Observatory in Hawaii, the Very Large Telescope in Chile, and even amateur astronomers with advanced infrared gear scrambled to get a look. Though Neptune is over 4 billion kilometers away, something extraordinary was visible. Faint atmospheric disturbances, massive storm-like swirls where the impact occurred. It's like watching Jupiter after Shoemaker-Levy 9, except this time it's Neptune, and the scars could last for years. NASA's Hubble Space Telescope was quickly tasked to monitor Neptune as well. Though Hubble's aging optics weren't as powerful as Webb's, it could still track long-term changes in visible light, complementing Webb's infrared data. Meanwhile, the Atacama Large Millimeter Array, or ALMA, began studying the aftermath by analyzing